Now in this video, we will see a very important point in group 16, oxygen family. First, we will see about the anomalous behavior. Anomalous behavior of oxygen. So as you know, in group 15 or in group 12 and 13, group 14, this tendency is exhibited, and this property of anomalous behavior on anomaly in character is exhibited by only the first member of all the particular groups. And you know what is the statement? What is the definition? That when oxygen, the first member of the group, differs from the rest of the members of its own group. It differs from the rest of the members of its own group. It's called anomalous behavior. So this is the statement of anomalous behavior. And so what are the points due to which we can say that it differs from the rest of the members of its own group? So the points are, first is its very small size. It's very small size. You know, oxygen is the first member, or in any other group, first member is the smallest. And so this is the key point. It is the first smallest in size. And other point, you know, the small size is due to its ability to complete the octet by the gain of electrons, gain of 2 electrons. So as it requires only 2 electrons, it has 6 electrons in the valence shell, so it needs only 2 electrons. So its electronegativity is second highest after fluorine. So this is very important point, that it ranks at second place. It ranks at second place in terms of electronegativity, means tendency to gain the electrons and become stable. So like formation of oxide ions. So this is a second point. Now coming to third point, it lacks d orbitals. You know, d orbitals are not present, or in any case we expand its octet, so it can never exceed 4. So it lacks d orbitals, and as a result its covalency cannot exceed 4. So its covalency cannot exceed 4. Now other point, you know, it is its ability to, so oxidation states as, you know, OF2. See, OF2 here, fluorine -1. So here oxygen, it will be 2+. It is surprisingly, oxygen being most non-metallic, it ranks second, but you know, here there. One more compound which is not, you know, have been confirmed, but at some places you can find O2F2. O2F2 is one compound where, you know, it has valency of +1 also. So this is the anomalous behavior of the oxygen, and such behavior is not exhibited by any other element. Now coming to very important part, its chemical characters or chemical properties of members of group 16. And so here we will see first reaction with hydrogen. So as you know, any element when reacts with hydrogen, there is formation of corresponding hydrides. So corresponding hydrides are formed. Corresponding hydrides are formed. In any case, like oxygen form oxides, nitrogen form nitrites, sulfates are formed by the sulfuric acid, nitrates by the nitric acid, chlorides by the hydrochloric acid. So similarly, when any element reacts with hydrogen, it is called as hydride. And so, see, H2O, water is the hydride of oxygen. Then H2S, then H2PE, then there is H2PE, then we have H2SE, then H2PE, and of course we have H2PO. They are the hydrides. This is water. This is hydrosulfide. So here, very important point to note about the hydrides, as in case of group 15. We'll see about the different conditions. And so, first we'll see about first point, nature. So children have to keep in mind, water is the only hydride which is essential for all the living organisms. So water, H2O, is only non-toxic hydride. Only non-toxic hydride of group 16. And rest are highly toxic. Highly toxic, this thing. About H2S is a gas, water is liquid. H2S is highly toxic. Plunging on highly toxic gas, and it creates vomiting, irritation, etc. Rest, H2SE, H2 PE, they all are poisonous. So this is about the nature of the hydrides. Now other point is the stability. So as a general term, stability means, you can say, thermal stability. So, ongoing from top to bottom, there is a decrease on moving from top to bottom. Stability decreases. There is decrease in stability. Why decreases? Because of increase in size, as size of elements increases. Size of elements increases down the group, and H and E for the element, He bond becomes weak. So this is there about the thermal stability. Now next is Reducing character, so as a general trend, as you move from top to bottom, the size of the element increases, and so the E for the element EX bond, this bond becomes weaker. So when the bond becomes weaker, what happens? On moving from top to bottom, so on moving from top to bottom, reducing character increases. So you can say reducing character increases down the group, and so there is S2O. So what do you know? It is unable to reduce anything. Then S2S, then S2SE, then S2PE, and S2PO. So there is the increase. So same is the case with stability. And so because the here in case of oxygen there is a very small size. Other way, oxygen is very small in size, so hydrogen is bonded. So the force of attraction is stronger, so it is indicated here. Now, in case of this S2PO, the size of polonium is the largest, and as a result, the hydrogen ions are lost very easily. And so same is the case with the thermal stability. So this is about the reducing character. Now, next is the acidic character. Acidic character of hydrides. So acidic character, same is the case. Like S2O. S2O, it is not acidic. Then coming to S2S, there is slightly increase in acidic strength. Then S2SE, then S2PE, and then S2PO. So same is the case here. Acidic character increases. There is increase in the acidic character. Acidic character increases down the group. Acidic character increases down the group. Why it increases? Because of the size factor. Size of oxygen is smallest. So there is a very strong bond between oxygen and hydrogen. So this bond, in case of this, we have this bond. So this bond is the strongest. In case of other, let me take the case of this hydrogen chloride. So here, this bond is, it is the weaker. In case of this, the bond will be weakest. And so this has poor tendency to hold together, and so acidic strength follow this trend. So this is about the acidic character of the hydrides. Now next is reaction with oxygen. So members of this family, they form two types of oxides, rather EO2 and EO3. This is EO2, E for element. This is dioxide, and this is trioxide. So this is general trend. All do not form dioxide, do not form trioxide. But sulfur. First take case of water. So this, water is there. So water is, it is the hydride. So it is there. But oxygen reacts with themselves, and there is formation of ozone. So ozone is the oxide of oxygen. So this is there, and so now I am going to explain the last part, that is the formation of halides. So halides of oxygen family, they have a wide range of characters, and the halides are formed in different categories, like EX2, EX4 and EX6. EX2, they are called dihalides. Then EX4 tetrahalides, and they are called hexahalides. And different halogens have different character. Like fluorine is most electronegative. Iodides are least electronegative. In fact, iodides are found to have slightly ionic character because of the largest size of iodine. Iodine is electropositive in nature. Unlike fluorine, fluorine is most electronegative element. So the point is there is very large number of variations in different characters, whether they are physical character or they are the chemical characters and stability. For example, see SF6. SF6 is a gas. SF6 is a gas and it is insulated. It is insulated. See, insulated. And it is used in high frequency generators. Used in high frequency generators as dielectric material. So see the condition that SF6 is inert. It is totally inert. It do not catches fire. High frequency means very high speed. The generators in which at the thermal stations or the hydroelectric stations very high. So and SF6 it has octahedral. It has octahedral shape. Now coming to like this SF4. SF4 it is it is also gas, but it can be very easily converted into liquid. Gas, basically gas as well as liquid. This SF6 can be converted, but it is very high pressure required. Now SF6 is there. SF4 it has tetrahedral. It has tetrahedral like this. Same is the case. Like SeCl2, it has linear. It has linear. So this is the variety, and it is a gas. All are covalent. This is very important point to note. All are covalent. All are covalent. This is the first point, and form oxyacids. Oxyacids can dissolve into water. On dissolving in water. And iodides, you have to keep in mind, iodides are having ionic character. Iodides are having ionic character. So this is about the general description about the halides of chalcogens.